wanted to start going over chapter 6 for those of you that need to retake or at least bump up your score. You're going to have this packet. You should have this packet right here that goes over all the notes for chapter 6 and some specific exercises. And I'm going to walk you through them, starting with section 6.1, and then we'll go through each section from there. You're going to see a little bit of repetition from some of the activities that we've done in class. And this is also very much modeled by the book. So basically, if you went through the book and did a lot of these, you could do a lot of these exercises or ones that are very similar to them um, to help yourself prepare for the retest. Okay, so everyone has to fill out the notes except for my students who got an A on the test. If you wish to fill out the notes and you got an A on the test, then you will be rewarded accordingly. I will give you some extra points on a test or test plural. So basically what we're talking about first section is the difference between basically random variable and the probability distribution of discrete random variables. Okay, and that's what the table was that we were looking at. So a discrete random variable takes a fixed set of possible values with gaps in between. So there's a value and the probability of it occurring, and that's what we're looking at. Okay, and to make it a good probability distribution, each value has to be between 0 and 1, and the sum of all those probabilities has to be 1. Okay, so as an example, in 2010, there were 1,319 games played in the National Hockey League's regular season. So we're going to select one of these games at random and find the number of goals selected and give probability distribution and stuff for this. So first thing we're trying to do is to show that the probability distribution is legitimate. So if I took a calculator and I added all these up, they would add up to 1. And each one of these probability distributions is in between 0 and 1. Okay, so I wrote, it is a legitimate probability distribution because all the probabilities are between 0 and 1, and the sum of the probabilities is equal to 1. You don't need to do this histogram, but it's a good idea to take a look at it so that we can describe it. I created this. It's really not that hard. It's just 9 bars here. So as you can probably see that this is skewed to the right, which means that the majority of the games are on the lower side, scoring side, which makes sense for hockey. Okay, so it's unusual for a team to score more than 6 goals. Okay, so then we're asking, what's the probability that a number of goals scored by a randomly selected team in a randomly selected game is at least 6? So what we're looking for is, what is the probability that they're 6 or greater? So what I did is I took and I added all these sums up. Okay, so what I did right here is I took the probability for 6, 7, 8, and 9, and that ends up to be 0.061. So around 6% of the time, the number of goals scored is around 6, okay, or greater. Okay, so moving on. The other thing that you guys needed to learn to calculate in this section was the mean expected value. And that was actually not too bad. You took the value and you multiplied it by the probability. And you did that for each item in the distribution, and you added them together. Remember, this thing right here means summation. And each these just mean that you're picking the probability that goes with the x value here. And then as far as calculating the variance and standard deviation, we did this hands-on in class, and you are going to have to do a little bit of that as well. So the variance is you take the value, the x value, and subtract the mean, which is what you calculated up here, and square that value and multiply it times the probability. When you add all those up, that's equal to the variance. Now, you're going to get some practice doing this, and I want you to do that a couple of times just so you can understand how this is being done. Most of the time, you're not going to have to calculate it by yourself, okay? And then remember that the standard deviation is the square root of this variance. So you take this whole thing and then take the square root. The other thing that's important in this is being able to interpret what the mean means and what the standard deviation is. So these are basically your scripts that you're going to have to follow when I say calculate and interpret the expected value. Okay? And also calculate and interpret the standard deviation. So interpretation is if we perform many, many trials, we would expect the average of whatever we're measuring to be this. Okay? So that is your mean. The standard deviation, it says on average that whatever we're measuring will differ from the mean of by about this much. So here, the mean is in this thing here. So we put the expected value in this part, and then the standard deviation goes right here. Okay? So right here, they have a calculation, just a really good example of actually doing the mean, expected value, and the standard deviation, and also interpretation of that. So if you want to, that's a good thing for your reference, but it's a good thing to study. So definitely hold on to that if you need to. Okay, moving on. We're going to get through 6.1 and then I'm going to stop and then we'll talk about 6.2 separately. I want to do each section separately and I want you to be able to do these practice problems, okay? So if you do all this and pay attention to this, you should do very well on the retake if you feel you need to do that. So we're going to have to, you could do this mean and standard deviation on your calculator if you wish to. I just rather just do it manually, okay? But you're more than welcome to do that. So if you'd like me to, I can show you how to do that in class. But again, this is pretty much just as easy to do that. So I can go ahead and show you that with a calculator. So what I'll do, hopefully this thing shows up okay. Well, I'll show you next time with that calculator. So remind me to show you a time with the calculator. Okay. So again, I'm calculating the mean and standard deviation and interpret its value. Okay. So I'm going to calculate this whole thing right here. And actually, I'm going to put it into my calculator. So I'm going to go into Stat, Edit, and under L1, I'm going to enter 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then L2, I'm going to run in my probability values, which are right down here. So this is 0.061, 0.1, I'm sorry, 0.154, 0.228, 0.229, 0.173, 0.094, 0.041, 0.015, 0.004, and 0.001. Okay, so it says calculate the 1-var stat. So to do this, and again, I don't think it's showing up, rats. I'm going to press stat and go over to calc, and I'm going to choose the option 1, which is 1-var stats. And I do frequency, the list is L1, and under frequency list, I enter L2, which is second L2, and then I calculate. So my mean is 2.851, and the standard deviation is 1.63. Okay, so on average, the amount of goal scores of goals scored in a hockey game a I should say random hockey game is 2.851. And then to interpret the standard deviation, I'm going to say that on average, the distance or the difference, I should say, difference between the mean number of goals scored, which is 2.851, and the actual is 1.63. Okay, so you can do that as far as a interpretation. So again, I want you to practice doing that. Go ahead and calculate the mean and standard deviation. Again, I can do this probability distribution with my calculator. Oh, that showed up nicely. Oh, so maybe I just need to do that. So let me show you this on the calculator for you guys. So now that my calculator is showing up, I'm going to do stat. Why is it not working? Edit, and under L1, I don't know why that's not working now. That's annoying. Okay, under L1, I'm going to enter 0, 1, 2, 3, 4, and 5, okay? And under L2, I'm going to do 0.03, 0.16, 0.30, 0.23, 0.17, and 0.11. Okay? So from there, I'm going to go stat calc, and I'm going to run one of our stats. And again, my frequency is L, my list is L1, but my frequency is L2. So press L2, and this is what I get. So my mean was 2.68, and my standard deviation is 1.31. And that works out nicely. I don't know, again, I'm so annoyed. I don't know why that's not showing up. Okay, so that is the mean expected value and standard deviation of a discrete random variable. So a continuous random variable, I didn't fill this part out, so please forgive me. In this one right here, 6.1b, a continuous random variable takes on any value in an interval of values. And the probability distribution of x is described by a density curve. Okay? The probability of any event is the area under the density curve below the values of x that make up that event. So what I'm talking about here is we're going to be using table A again, or normal CDF. Okay? The probability model of a continuous random variable assigns probability between 0 and 1 to each possible value. Since it's continuous, it has infinitely many possible values. And if you assign one particular outcome, usually it's 0. And only an interval of values will give you a numerical probability other than 0. Okay? So that's when we're going to go into 6.1. All right, moving to the next one. We just two more things. Okay, so this is an interpretation of finding the probability of this. Now, what I can show you is I'm going to show you with the calculator as well. The heights of young women closely follow the normal distribution with a mean of 64 inches and a standard deviation of 2.7 inches. This is a distribution for a large set of data. Now choose one woman at random, call her height Y, If we repeat this random choice many times, what is the probability that this woman's going to be between 68 and 80 and 70 inches tall? Okay, so we have a mean. So what we could do two different things. We could plug this into the calculator, or we can calculate z-scores. So remember, we have to calculate two z-scores, one with the value of 68 and another with a value of 70, and then we take the difference of those two areas. Okay, so I do 68 minus the mean of 64, and I divide it by the standard deviation of 2.7, and I get some z-score. All right, and then this one I do 68 or 70 minus 64 divided by 2.7, and I get another z-score. Okay, and if I were to look these two up on table A, I would get specific values for them. But let me just go ahead and get the z-scores there. So I got 68 minus 64, and I divide it by 2.7. All right, and that gives me 1.48. And then I do 70 minus 64, and then I divide that by 2.7, and I get 2.22. Okay, so I looked at both of these on table A, and I take the difference between these two areas, and that would give me the probability. Now, if I wanted to do this a different way, I could do it using my calculator, which I would do second vars and do normal CDF. My lower bound would be 68, and my upper bound would be 70, and my mean is what we've been told, which is 64, and my standard deviation is 2.7. So if I enter that into my calculator, I get 0.0561, okay? And that's exactly what I would get if I took the areas and I took the difference. So when you're using your calculator, which is totally fine if you do, make sure that I would draw the normal curve. I would make sure that you write down that it's normal, what the mean and standard deviation is, so that you know what you're doing. And again, like I said, draw the curve and show that you're taking this probability, okay? This is only necessary when you're doing a short answer question, okay? So the same thing happens with here, and I actually worked this one out using the z-scores and getting the areas, okay? So we have weights of 33-year-old females, and the weights of a 3-year-old female closely follow normal distribution with a mean of 30.7 pounds and a standard deviation of 3.6. If we chose one random female, what is the probability that she will weigh at least 30 pounds? So that would be 30 pounds or greater. Now the thing to remember for this is when you're doing this, you're getting the z-score for 30 pounds, and that's negative 0.19. And then what happens is you find the area, which is right here, but because it's above, you have to do 1 minus that area, okay? So if it's above a weight, you have, or a value, you have to do 1 minus that specific area in order to get the value. If you're doing below, it's fine. It's exactly what the area is off of your table. So if I wanted to do normal CDF though, which I can do, I do second vars, normal CDF, and then I set my lower bound as 30, and my upper bound, I'm just going to put like a huge number, all right? And then my mean is 30.7, and my standard deviation is 3.6. And then I just plug that into my calculator, and I get approximately 5.77, which is approximately 58%. Okay, so if you do the table, you're going to get a little bit different number than what you get from the calculator. There's absolutely nothing wrong with that. Remember, I said they always have both with them. As long as you use your drawing and show the area and show that it's a normal curve and state the standard deviation, you're okay using your calculator. Just make sure that you put in as much information as possible because you want to make sure they know that you understand what they're asking for. Okay, so now we're back to linear transformations of random variables, and that's section 6.2. So I'm going to go ahead and stop for a bit and have us finish off. 6.2 is pretty lengthy. Um, so we'll have lots of practice with those. So make sure that you guys look through this section really well and your notes and the activities that we did, and then go back to 6.2 and we'll start doing that. Thanks a lot for watching.